Well, first off, I'm going to tell you that creation science would tell us that the earth is, if I was a really polite person, I'd tell you the earth's less than 10,000 years old, but I'm not a really polite person. God's still sanctifying me. The earth's about 6,000 years old, okay? And so just want you to know. Where does that idea come from? Bishop Ussher, and there's a really great article on it. If you want to read it, I can email it to you. But Bishop Ussher, this guy in the 1600s that was brilliant, actually connected Nebuchadnezzar in the Bible with Nebuchadnezzar in history and worked his way back through the scriptures, back through the genealogies, and he came up with a creation date of 4004 BC. Okay, he actually came up with October something, 4004 BC. And the first time I read that, I giggled, and I'm thinking, how does he come up with that? Well, because he actually knows that the Hebrews work on a lunar calendar, and he worked his way back to what would have been the creation day, Rosh Hashanah, on that year. He was brilliant, much smarter than I am. I had trouble understanding the article. Okay, the guy was brilliant. Anyway, so let's look at some evidence that supports that. Let's have some scientific evidence that supports that. One thing is the magnetic field of the earth. It's what makes compasses work. And the magnetic field has been measured since 1835. We know that it is deteriorating. Why is it deteriorating? Somebody tell me, why do we see everything in the creation wearing out? Do you guys know? You really don't know? Oh, we gotta do this. Okay. The reason everything in creation is wearing out is because Adam and Eve, God created a perfect world. Adam and Eve sinned. When everything went under the curse of death, all creation is in a state of death. It is all going downhill. That's why it talks about in Romans 8 that all creation is groaning to be restored to its original perfect condition. You've heard that before, right? So that's why we see the sun is burning up. The moon is leaving at 2 inches per year. The magnetic field of the earth is weakening. Every 1,400 and some odd years, it loses half of its strength, which is important to us because it protects us from cosmic radiation. It's not just for compasses, okay? So the point is that everything in creation is wearing out. Stars are burning out. Everything in creation is wearing out because the whole creation, I'm so sorry, I thought you would know that. The whole creation is under the curse of death. And that's why we see everything in the creation, and there are going downhill. And we see scripture verses that talk about that, and then it's all wearing out. And that's why in Revelation, people like me get so excited that when God removes the curse, he's going to put it all back. He's going to correct it. He's going to put it back to its original perfect condition. And we're going to be there if you know Jesus, you know, and I'm going to ride a dinosaur, and it's going to be fun. So the magnetic field of the earth is wearing out, and everything's wearing out because it's under the curse of death. And they've been measuring it since 1835. And I want you to notice we haven't taken one rock and said we carbon-14 dated or potassium-argon dated this particular fossil or whatever. We took the whole rock, and we've watched it since 1835. That's over 150 years. And we've checked it, and with that data, we see that the earth can't even be 20,000 years old. If you go back just approximately 20,000 years ago, the magnetic field of the earth would have been so strong, it would have been that of a magnetic star. If you went back 100,000 years ago from the reading I did, it would have been so hot that it would have melted the earth. 100,000. Now, I want you to get a grip on that number. 100,000 is not much. The evolutionists want us to believe that the earth is 4.5 billion years old. Billion. Okay, there's the billion. And I'm telling you the earth's approximately 6,000 years old. If the magnetic field of the earth were just 100,000 years old, 100,000 years ago, it would have melted the planet. Now, I want you to see the difference in these numbers. They don't fit together, do they? You can't get these two numbers together, can you? So the magnetic field, now, what they do, and those of you that had physical science, and if you're going to be studying physical science, you'll learn about this. They came up with the dynamo theory and tried to explain it, but it doesn't line up with physics, and it doesn't line up with the scientific evidence very well. And so actually, it lines up better with the creation model. The earth is very hot inside. It is losing its heat to cold outer space. Outer space is really, really cold. Really, really cold. Now, let's think, this one's easy. If you took a hot potato and you stuck it into a cold freezer, would it be a hot potato tomorrow? No, it'd be a frozen potato, wouldn't it? The earth is a hot potato. It is in a cold freezer. It is losing its heat at 10 to the 27 calories, that's 10 with 27 zeros behind it, calories per second, to outer space. Which means, with the heat that it is losing, it should have been stone cold frozen to the center by now, even with what it gets from the sun, over 400 times. Should have been frozen to the center. But it's not. It's still a hot potato, which means it couldn't have been in the freezer that long. That one's easy. Little kids can understand that one. They can get that one. So that one's not hard. The sun, this is, oh, yes, sir, James.
What causes the space to be cold if we receive heat from the sun?
Oh, that's very good. Okay. The space in between us and the sun would have some heat in it, but generally space itself is just above absolute zero, which is very, very cold. So that's why on the side away from the sun at night, it gets cold. And then when you come back and you get in the sun again, it gets warm. So right in between the path of us and the sun, it would be warm. But the reason we're warm, remember from physical science, those of you already had it, is our atmosphere grabs a hold of it, the greenhouse gases, and hangs onto it. If it didn't, like with our moon, if you're standing on the moon, one side is 250 degrees Fahrenheit hotter than the other side of your body because the atmosphere actually holds it in. So where it would not be in direct contact with those light rays, it would be cold. Does that make sense? And so as you get farther away, think about it, Mars gets colder, Jupiter, it's colder. The farther you get away from the influence of the sun, the colder it gets. Does that make sense? Okay, good question. And that kind of plays into this. This is called the faint sun paradox, and it's really kind of interesting. What they now believe that the sun, as you learn in physical science, and if you're going to take it still, you're going to learn about this, that they believe it's a nuclear fusion reaction where hydrogens ram into each other and they fuse together into helium, and that's what the actual reaction that fuels the sun. And so with that thought in mind, they say that the sun is getting brighter. That main sequence stars, which is what the sun is, get brighter with time as they're going through this process. And as they get brighter, they get hotter, and they actually burn up faster. And all of the evolutionists agree with this. So since 1972, they have this paradox. They have this problem. And what's the problem? Well, they believe that life started to evolve 3.8 billion years ago. 3.8 billion years ago, okay? That far ago. Well, if the sun is what it is now, if you go back that far, the sun would have been 25% dimmer and colder, which means the temperature on planet Earth would have been under freezing level, 31 degrees Fahrenheit, which means how could life evolve here if it was a frozen planet? This is why it's called the faint sun paradox. Now, how they've dealt with this, they have what are called, we call them rescue devices. They can't just leave these things alone that I'm telling you. So they've come up with ways of trying to explain it. Like within physical science, you learn about the dynamo theory because that's how they explain the magnetic field of the Earth problem. With the heat problem, the rescue devices, they say, well, the interior of the Earth and the exterior of the Earth are moving against one another and causing friction, and they're saying that that would continue to produce heat, which if you believe that, you also have to believe in a perpetual motion engine, which is not good physics. It doesn't happen. Things eventually wear down. And actually, I found this on the internet. I thought this was interesting that Carl Sagan, what they said back in 1972 was, well, we have to come up with something to explain how the Earth could have sustained life when the sun was that much fainter. So they said there must have been a stronger, look at the bottom one, it says there must have been a stronger greenhouse effect on the early Earth to hold in all that heat and keep it warmer. In other words, this really is a problem for the evolutionists. They can't figure out how, if you go back as far as they think they have to go back, the sun wouldn't have been bright enough to keep the planet warm enough. The sediments in the oceans, you have sediments, and I'm going to get this so I get the numbers right. You have sediments being added to the Earth's oceans, and there are 20 billion tons of sediments being added to the Earth's oceans every year. 1 billion tons of them, they believe, get subducted, which means they go under the plates. And so if the Earth were as old as they think it is, the oceans basically should be full of mud. A matter of fact, all the sediments in the ocean, at the rate that they're being added right now, could be accounted for in 12 million years. 12 million years. Let's see, let's get to million. All the sediments in the Earth's oceans could be accounted for in 12 million years. Well, they're missing a lot of sediments there, aren't they? And how do we explain how that got built up in 6,000 years? Well, there was this event called the flood. And there were a lot more sediments added at that time. And that's good evidence globally. Another one is the salt in the ocean. You guys remember from physical science, if you already had it, how the salt is added to the oceans by the sediments and stuff that are carried in. And there's only a small amount of the salt that is actually removed. And the point is, there's not enough salt in the oceans if the earth is that old. And all of the salt could be accounted for. Let me get this right. There we go. All the salt could be accounted for in just 42 million years. So once again, we're here. 42 million years. Now you might say, well, gosh, that's still a lot of salt. Well, that's at its current rate. And once again, there was this thing called the flood that added a bunch of extra sediments and therefore extra salt. And so not a problem explaining it, but they have a problem because, like, who stole all the salt? My husband says I eat way too much salt. I know you're an old Trekkie. If you ever watched the old Star Treks, there was a salt monster suck the salt right out of people and kill them, and that's terrible. But anyway, that's what happened here. See, the salt monster sucked it out. Anyway, okay. And then another one that's pretty neat, let it go, is bacterial DNA. And they found, get this, they found bacteria that are in salt crystals, that the evolutionists date the bacteria at 250 million years old. Okay, so the evolutionists are dating these bacteria at 250, let's see, nope, yep, that's right, million years old. There you go, that's how old the bacteria are supposed to be. And you're going, okay, well, DNA can't last that long. And they found the DNA, first off, DNA can't last that long. But not only that, the DNA in these, they call them Lazarus bacteria because they resurrected them. The DNA in these, no kidding, is very similar to present day DNA. And they're going, well, wait a minute, if they evolved and they know the mutation rates, then they shouldn't look this much like present day DNA, but they're not that different. Well, if they're only a couple thousand years old, it's not a big deal. Anyway.